And today we're going to talk about multiplication and division word problem structure. First, we're going to talk about importance of teaching multiplication and division together because they're really connected. Let's see. In these slides, I have some overview for you. So first, to realize that multiplication and division are connected. Multiplication involves counting groups of like size and determining how many are in all. While division names a missing factor in terms of the known factor in a product. So that to be said, even though the problem was a multiplicative problem, it could be solved by using division. There are standards that are covering by multiplication and division in common core state standards, and they are starting with the third grade. Every teacher should know different kinds of multiplication and division structures. Starting with equal groups or measurement quantities or comparison, so far so on. The only objective is Arizona standard that Common Core State Standard doesn't cover is combinations, but we'll talk about that later. Here is the poster that I created. So if you look into that, you can see how we can model a problem structure of multiplication and division. There are four actually. One is equal groups, another one is comparison, combination, and fourth one is product of measure, and you know it as area or arrays. Each of these structures are, you can think of them a little bit deeper by getting into understanding that each subgroup, I haven't made these schemes that you can use with for you to better understand, or maybe for your students, they can verbally create different problems together with you. So if we look this one, we can make sure that we understand there are four different ones, equal groups. Also, in equal groups, we can see then there are three different kind of problems that our student can deal with. One where when product is unknown, and the number of groups is known and size of a group is known. This is called multiplication problem, and its semantic equation is when you multiply two factors, you get a product as your answer. While another multiplicative equal groups structure is when we don't know size of a group. So we know that semantic equation can be written as number of groups known, and then unknown is size of a group, and we know the total or product. In this case, the calculational equation is division, while semantic equation represents size of a group unknown. The third case is if we don't know how many groups we have, but we know size of each group. And we also know product or total of a product that we know. So that is semantic equation is unknown is a number of groups times known size of a group, and is the same as a product. When we want to solve it, we need to use operation division equation, which will have a product divided by size of a group will give us how many groups do we have. This is also called as a measure of, because if we have a product and we know how big is size is our group, we can take and measure off equal amount of value and we can find out how many groups do we have. Another one is comparison. Comparison is only have two values. It's a small value and large value. And then a smaller value is actually multiple. The larger value is multiple copies of the smaller value. So, and then we can have unknown in a different position. We can have a large unknown, which is multiplication, and we can also semantic equation for a small set then to not to be known. If we know large and we know how many times the small set is in a large set, we can figure it out by division how big is a small set. And then the third one is if we don't know a number of copies, but we know small set and large set. So we know the small and large, but we don't know how many times small set is in a large set. And also this is semantic equation, but we can use calculational equation to solve it, and that would be division. The third one is area product, which is interesting that it also can be found in missing one of the length or width, and then area is a product or a total. What is interesting for area measurement is that you actually multiplying like 1D length, and then you get totally different thing. Your answer is a 2D shape. So because the product are consist of squares. Combination or Cartesian model is used in Arizona standards, and that is also interesting that you can have a combination of maybe pants and a shirt, and then you get pairs. Your result are in a numbers of pairs. So there is also example how the one set could be known and pairs, numbers of pairs could be known. And then also so here you can see problem structure for multiplication and division, and then I have all three versions that could be unknown, product unknown, size of a group unknown, number unknown. And then we come to the problems. Here are the keys for every single structure that your kids can encounter from third grade, fourth grade, and even sixth grade. With sixth grade is using fraction actually. In this key, you have for each example, you will have a three different presentation, like a whole unknown, that repeated addition or multiplication, and it's three of the some of the problems are rates. It's kind of like a subgroup, but it's the same system of finding a whole by multiplying. And then again, this example are like size of a group unknown. We know how many groups we have, but we don't know the size of each group. And so that is called equal sharing or fair sharing. And then the next two examples are the rate examples. So far, so on, you can go all through those examples. These are comparison. As you can see, I created and then area model. You can see the key, how you can find the area, and then if a link are missing, how you can help students. And in the sixth grade, they're using, in the fifth and sixth grade, they're using fractions to find the area. So you can know that area is 1/2 of an inch squared, and then, for example, that length is 3/4 of an inch and width is missing. So you're going to use that to help students understand and divide with the fractions. Arrays also in the third grade and fourth grade, size of arrays, groups of stars, groups of marbles, or any things. And then combination problems, which is Arizona standards. You can see I put two kind of examples, like if you have a pants and jackets, and then if you have dice or coins to roll. Okay. If you need references, here is all these problems were driven from this book from John Van de Waal, and also in Common Core State Standards, there are the tables. If you scroll down, you can see when exactly this document is, which grade needs to master different kind of a structure problem are here. I also made additional, if you want to read about it, so just these 2 pages from that book.